Hey everyone, welcome back. In today's video, I'll be showing you how to build an advanced line follower robot with integrated obstacle avoidance. But first, let me show you a quick demo of the robot in action. For this build, I'll be using a custom-designed PCB specifically made for this project. If you're new to the channel, make sure to hit that subscribe button. And don't forget to turn on the notification bell so you never miss an update. Check out my previous video on building a fast line following robot. Let's see the components we need. I'm using my custom PCB, which integrates the Arduino, a buck converter, the L298N motor driver, and an OLED display, all in one PCB board. In addition to that, I'll be using a separate IR sensor PCB, which also includes ultrasonic sensors. We're powering the robot with 25 GA gear motors, hex couplers along with L mounts for secure motor attachment. For the chassis, I've crafted one out of a 5mm PVC whiteboard. These are the components also required. Now assembling the IR sensor PCB using TCRT5000 and ultrasonic sensor. Now creating necessary holes in the chassis to place components. Attaching mount with the chassis. Then attaching motors with mounts. Attaching hex coupler with motors. Now assembling the main PCB board. Then place the main PCB board on the chassis. Attaching boost module in the bottom of the chassis. Connecting T connector at the input of the boost module. Connecting the output of the boost module to the power input of the main PCB. Connecting motor terminals with main PCB board. Connecting sensor the IR sensor pins with the main PCB of line follower robot. Finally, all the connections are done. Now check providing power to the PCB for testing. It's working properly. Now attaching wheels. Coming in the coding part. Unzip and open the code in Arduino IDE. This line includes the 𝐀𝐬𝐥𝐚𝐦 library, which is used to control graphic displays, includes the 𝐁𝐬𝐴𝐺 library to interface with ultrasonic distance sensors. Pin 4 is used for both trigger and echo, and the sensor's maximum distance is set to 40 cm. Defines motor control pins. The threshold is set to 500, the value used for digital conversion of the IR sensor value. This part will display the front page. If button 1 is pressed, the robot enters line following mode by calling the line follow function. If button 2 is pressed, the display value function is called to show sensor values on the OLED screen. Some functions like analog value and motor test are commented out for future implementation. Now in the line follow code, if the robot is centered on the line, sensors 2 or 3 detect the line, it proceeds to line following logic. If an obstacle is detected, the robot calls the obstacle avoid function and activate the obstacle avoid code from the sonar sensor tab. Select the board Arduino Nano. Then select the proper processor for your Arduino Nano. In my case, it's at Mega 328-old bootloader. Then upload the code. Here we have two options. If you press button 2, then it will show the sensor values in the OLED display. If you press button 1, then the line following code will be activated. Let's see run the robot on track.